In this video, we are going to continue discussing hypothesis testing, but now what we're going to do is we're going to transition to where we do not know our sigma. We do not know our population standard deviation. When we do not have our population standard deviation, we must use what is called the student's t distribution. This is using the t-test. We did this back when we were discussing confidence intervals in the same manner. When we were not given the population standard deviation, we had to use the t-values. The t-values are going to be slightly different. Okay? We will use this chart right here, table A3, because this is the student's t-distribution. Remember, when we're looking at the t-distribution, we're looking at degrees of freedom. Degrees of freedom, remember, is n minus 1. So we take our sample size and we subtract 1 from it. Now you'll notice that this says it's at the area in the right tail. So that's why it only gives you positive values. So if we need a negative value or something like that, the t-distribution is also symmetric, so you can fold it over upon itself. Basically what these values are these are the absolute values. So we make them negative or positive based on if we have a left-tailed or a right-tailed test. We state the hypotheses in the exact same way. So our null hypothesis is still going to be mu equal to some value, and our alternative hypothesis will be mu less than, greater than, not equal to that exact same value. We will still have an alpha, and we can still find those critical values based on the level of significance. We're still going to compute a test statistic, but in this case it's going to be a t-test statistic. That t is going to look like x bar minus the mu divided by the sample standard deviation over the square root of n. These are calculated the exact same way as the z was in the previous section. The difference here is the t. Now, when we're computing the p-value, it's actually strictly going to be an estimation. It's going to be between two values. And I'm going to get into how to do that where we actually look at an example. Interpreting the p-value is the exact same thing. We reject the null hypothesis if the p-value is less than or equal to the alpha. And our conclusion will be stated the exact same way as the previous. So let's look at an example of where this would be a t-test. So example 1 says a parenting magazine reports that the mean number of phone calls teenage girls make per night is at least 4. For her science project, Ella sets out to prove the magazine wrong. She claims that the mean among teenage girls in her area is less than that reported. Less than that, okay? We already know that our null hypothesis is going to look like this. Our alternative hypothesis now, based on this less than, will be here. And the original stated value was 4. So mu is equal to 4. Ella collects information from a simple random sample of 25 teenage girls, so n is 25, at her high school, and calculates a mean. So calculates a mean of 3.4 calls per night with a standard deviation. Notice, it tells us, yes, this is a standard deviation. It does not tell us this is the population standard deviation. It does not say population standard deviation or sigma is. It just says with a standard deviation. This indicates that this with a standard deviation is these 25 teenage girls have a standard deviation. The sample has this standard deviation. So S is going to be 0.9. calls per night. Test Ella's claim at the 0.01 level of significance. So alpha is 0.01. We want to use the p-value method. So we have our alpha 0.01. This is going to be a t-test because we do not have the population standard deviation. We have this sample standard deviation. This is a left-tailed test. So we're looking at this over here. So is our critical value t going to be positive or negative? Well, it's on the left-hand side, so it will be negative. For a t-test, we have to know our degrees of freedom. Degrees of freedom, recall, is n minus 1. So in this case, it's 25 minus 1. Degrees of freedom are 24. Okay? So let's come over here. We want to go down to the 24 row. And this is where we're going to stay the entire time for this test. Now we don't have the area in the right tail. We just have an alpha being 0.01. So we have this. So we look here, right here. But recall that since this is a left-tailed test, we're actually going to use a negative 2.492. So we're using a negative 2.492. That is our critical value. Okay? So now let's go to our test statistic. Again, our test statistic is calculated the same way, but this time it's a t. So it's going to be 3.4 minus 4 divided by 0.9 over the square root of 25. So 3.4 minus 4 is going to be a negative 0.6. 0.9 divided by the square root of 25 is 0.18. So our t is a negative 3.333. So it's going to be over here. Now, to find our p-value, negative 3.33, we're going to come back over here to the t-chart, and we are looking at still this particular row. We want to look at this row the entire time because that's our degrees of freedom. We had our t being a negative 3.33 that we calculated. Okay, well, we don't have any negatives here, so we look up a 3.33. So what I'm going to do is I'm going to look in this row and find out where a positive 3.33 would fall. So looking here, 3.33 would be somewhere between here. I don't know exactly where. I could just estimate where. It's between these two values. I'm going to follow that up. I'm going to follow this up. So I am between these two values. So when we're looking at a p-value for a t-test, all I can do is I can estimate it. I cannot get an exact value. It's between these two values. Now looking at this, 0.025 and 0.001, this number over here on the left side is actually the larger of the values. So wherever I put my p-value, I'm going to put the larger value over on the right side. I'm going to put p-value here. And then I'm going to put the 0.001 here. My p-value is between these two numbers. And I have the less than symbols as long as I put the largest number on the right side, which makes sense because whenever we're looking at a number line, the larger value is on the right side. So what you're doing whenever you're looking at the p-values, you're actually going to flip these values when you bring them over here. Now looking at these two values, comparing to the alpha, I want to compare this to the alpha of 0.01. Well, I can kind of do that over here. 0.01 is here. These are down here. So my alpha is actually larger. So my p-values are less than my alpha. So I will reject the null hypothesis. And we also found that by stating, here is my test statistic. It is in the shaded region. So there is sufficient evidence at the 0.01 level of significance. And I like to put in the level of significance because at a different level of significance, it may or may not be true. Significance to support Ella's claim that the, and it might help if I don't put two that's, that the mean number of calls for teenage girls in her area is less than 4 calls per night. Okay, so I want you to practice a couple of T's. In the next video, we will do a couple more examples.